Good morning, friends. I welcome you at host-tune-perform.com. I am Anand Goyal and I will be your trainer for application monitoring course. So for this course, I have chosen two softwares. One is Prometheus and second is Grafana. So what is the purpose of choosing these two softwares? Are there some other alternatives? We will discuss a lot of things during this course, but for now, during this chapter, we will focus on the theoretical part. Now, what exactly is application monitoring and who should look out for this course? So the application in terms of IT world can be an Android application, it can be a web application, it can be a Mac application, it can be a command line application that is a desktop application. So people can go ahead and make a desktop application using Java, using Python, or else like there are a lot of other type of applications. So in another sense, like you might be a tester, you might be a developer, you might be a system engineer. So who exactly should look out for this course? So if you are a tester, automation tester, you might be writing up things in Selenium or maybe some other language which you people are using for your framework. So anyhow, like the important part is you are creating up an application. If you are a person who is creating up an application and worried about the performance of the application and need to know like how it will perform with multiple users, and you need to know like what will be the exact problem causing area, and you want to instrument it, then this course is for you. So what exactly is instrumenting? So as an application developer, you will be writing up a lot of modules. What is a module? Module can be something where you are like allowing a user to log in, or a module can be you are saving up some data which is given by your user, or a module can be a user is requesting something and you are providing him that thing. So there will be a lot of files which you will be writing up using some code, and when you say that you are instrumenting it, so you will be adding up some extra code. What will this code do? What will this extra code do? This extra code will like keep track of the timings when a user comes in and logs in. So it will keep the track of the timing of like how much time the server took to make sure that the user is authentic and it responded back to the client. So you can understand it this way, like instrumenting a server means like you have put up an extra code on a server which is tracking how much time your code is taking. So what all languages you can instrument? You can like instrument almost all the languages which are commonly used within like the IT domain using Prometheus, and this is the most powerful feature which I feel about Prometheus, that is instrumenting. So what exactly is Prometheus? So Prometheus is time series database for monitoring IT infrastructure and applications. What exactly is time series database? I would like you to focus on these two words. One is time series database and another is monitoring. So, for example, you might be monitoring CPU usage of a machine or a process within that machine. Yes, using Prometheus, you can measure the total CPU utilization of a machine and also the CPU utilization of a single process within that machine. So, I have done this using custom scripts. Obviously, we will be discussing it in this course, but today let us focus on the theoretical part. So what exactly is time series? When you say time series, you are measuring up CPU utilization, and at time A, the CPU utilization will be X. Say for example, then at time B, the CPU utilization will be Y. At time C, the CPU utilization of that machine will be Z. So as the time changes, the value of one counter, that is CPU utilization, changes. So this is what the Prometheus database keeps tracks of. It will save all of these data. At time A, the CPU utilization was X. At time B, the CPU utilization was Y. Similarly, when we want to see like how our system was performing one week back, so we can go ahead and like query something on the database and then see like 1 week back the CPU utilization of this machine was this much. Second thing which I want you to keep track of is monitoring. So why I am emphasizing on this word, which is monitoring, because while like the developers of this tool created of this database, they took this word very seriously. Like why, what does this mean that they took up this word very seriously? It means that while creating of this database, they created of this database in a way like it has various data types. So these data types are maintained in a way which are meant for monitoring. So the purpose of this tool is for monitoring. So the next thing is, do we have some other open source technology which we can use instead of Prometheus and Grafana? The answer is yes. So we can use like the tick stack. It is called as tick stack, where like the word tick has some representation of four tools. One is telegraph, another is influx db, the third one is chronograph, and the fifth one is capacitor. So what is the purpose of these different tools? For example, influx db is something which you can compare up with Prometheus, right? But Prometheus also does the job of telegraph and capacitor. So all of these three tools, if you combine all of these three tools job is done by a single tool, which is Prometheus. Second, the last tool, which is chronograph, that is for visualization. What exactly is visualization? Visualization is nothing but something like this. So visualization is a way in which you are getting up your data into a form of graphs. So I have installed Grafana on my system locally. So you can see up my browser is like locating to localhost and the port is 3000, and this is installed locally on my system. And you can see that we are fetching information about CPU usage, that is total CPU usage of the machine and the total memory usage of the machine. Then we also see that we also have the CPU usage of top 10 processes, the processes which are taking up the memory, like the top 10 processes, right? So you can see that the maximum CPU usage is being taken up by tracker store, and the maximum memory is taken up by Nautilus. So these are few processes which are running inside these machines, and like we have prepared a chart, a graph. This is what is called as visualization. Similarly, the software which is bringing up this data consistently is done using data collector, and these data collectors in Prometheus are a part of Prometheus. So in tick stack, you need to have telegraph, which has data collector for different sources. Then these data sources are like being transferred to the time series database. Database is just somewhere where you are keeping up the track of the entire data. So as we have SQL, in which we have tables and we store information in tables, we have some relation between the tables. So it has a different purpose. It has a purpose of building up applications. Like it is a database for application. In a similar way, Prometheus is a database for monitoring. But if you need a time series database other than monitoring, then I would have like chosen up Influx DB and not Prometheus. But here today we are having this course on monitoring. That's why we are like choosing up Prometheus. Similarly, capacitor is something which is for alerting. That is real-time data processing. Like when the CPU usage goes above 90%, there should be an email which should be triggered automatically. So capacitor is something for that. But Prometheus has this support, inbuilt support. It has something called as alert manager, which is doing up this job for Prometheus. Now let us discuss on the differences between Prometheus and InfluxDB. So InfluxDB for querying, because it is a database, so you have a lot of information inside this database, and you want to fetch it. Obviously, before, like, if you cannot fetch the information of a particular instant, you cannot prepare up these graphs, right? Because it has the data for, like, say 1 year, 10 years. So it has a long list of database, but these graphs are showing you up the data of the latest fetch, right? Because it cannot show you the data of the 1 year back, because if it will show you the data which was there 1 year back, it does not make any sense. So if I come back over here, InfluxDB uses a language called as InfluxQL, which is very simple to SQL. If you people know SQL, already know SQL, then yes, it will be very easy for you to use InfluxDB. But Prometheus uses its own language which is PromQL. So people might think like with Prometheus you will have to learn a new language. That is true. But I will also tell you, if you go ahead and learn SQL, it will take you 30 days. But if you go ahead and learn PromQL, it will just take you 2 days. It is a very simple language because the purpose of Prometheus is basically for monitoring, right? Then I will say that I have like felt it completely that the CPU consumption of the memory and like CPU of a machine that is holding up the InfluxDB is higher. So if you set up an InfluxDB server, so and query an SQL statement, right? So it will take more CPU and more memory. But if you will have a Prometheus server instead, and if you will query it using PromQL for the same scenario, it will take less CPU and memory. Then InfluxDB supports all of these data types. So it supports float, int, bool, string, but Prometheus only supports float. It does not support any other data type as per, because it is for monitoring, and in monitoring you basically have numbers: CPU utilization, number; memory utilization, number of users logging in, number; the duration it took while the person logged in, again number. Like number, or you can say like float, right? Because it is a decimal number, right? Then the third thing is like Prometheus can store the time in milliseconds, but InfluxDB is more advanced and it can store up the time in nanoseconds. Then if we see that Prometheus uses an append only file per time series approaching for storing database. What this means, like when it stores up database, it only appends the previous files for a counter. So it just keeps on appending it as the times come in. It keeps on appending it. Like today is 16th, then it will like put up the data for 16. Then tomorrow comes and it becomes 17, it will append and put up the data for 17 in the same file. But InfluxDB uses a like different method of storing. Obviously we will not discuss about InfluxDB during this course, but I just wanted you to understand the differences between Prometheus and InfluxDB. Last but not the least, Prometheus is developed to pull matrix. So what is difference between pull and push? So this is what is meant by the last term, which is pull and push. So the Prometheus server is a pull matrix. It means that whenever you are getting some data, so when you say that you are storing data in a time series database, you must get some data from somewhere. That is the target, the machine which you are monitoring. Say for example, you are monitoring a Linux machine or an Ubuntu machine. So when you are monitoring an Ubuntu machine, what will InfluxDB expect? InfluxDB will expect that the monitoring machine, that is the Ubuntu machine, should send the data to InfluxDB by itself. So that is the push mechanism. But in Prometheus, the Prometheus will scrap the HTTP endpoint. What is scrapping? What is HTTP endpoint? We will discuss about it. Just try to understand this way. Prometheus will pull the data from the machine. The machine will not like send it to the Prometheus server. Prometheus servers will go like after some interval, like after say you have set up an interval of 10 seconds. So after every 10 seconds, it will go to the machine and ask, do you have, like, please give me the information of your current state. So the machine is not itself sending the data. The Prometheus will go and ask the information and then it will take it. So why do we choose Prometheus? So as per me, like these 3 points are the major things because of which I have chosen a Prometheus. One is like the client libraries. It gives us for instrumenting. So we have already like taken up an initial level of understanding on instrumenting, right? So it gives a lot of libraries for instrumenting. Second, it allows service discovery. So if you people are already aware of Docker and Kubernetes, that will be very helpful. If you are not, then please do not worry, we will discuss about it. In short, like what is service discovery? What happens in Docker and Kubernetes is like when you're running up an application in production, you run it inside a container. So these containers are created automatically as and when required. So whenever these containers are created automatically as and when required, they keep on changing up their IP address. When they keep on changing up their IP address every time, we cannot tell Prometheus to take up the data from that machine by itself using a static IP. Why? Because like we have already discussed, like Prometheus is a pull mechanism. It means Prometheus will have to reach the target and ask for the data, right? So what is service discovery? It tells like even if the IP address keeps on changing of that particular container. So like there might be like, an instance like you are using Kubernetes or you are using Docker Swarm for orchestration. You can use any one of them or maybe some other tool. So there are some particular support which are there in Prometheus. It does not like you can create up your custom code for orchestration. The Prometheus will not support it. It supports some particular orchestration engines, and like it can only discover the IP address of the containers which are contained in these engines, like in these containers, right? So we will go deep into it at a later time during this course. As of now, just try to keep yourself on the upper surface so that you understand the words, grasp the word, and go ahead later for an advanced level for the same. The third point I feel Prometheus is good is like it is based on HTTP endpoints. HTTP is a very commonly used language, and like most many of the developers, like 99% of the developers are very comfortable with HTTP, and that's why like it is very easy to implement. It scraps HTTP endpoints. So we will discuss about it again in some time. Then it is fast time series database. We have already discussed about it, and it has a built-in support with Grafana. What is Grafana? Grafana is nothing but the visualization tool. So it has a built-in support with Grafana. So now let us see how exactly the time series database looks. So you can see it over here that there are a lot of values which are over here. So these values, the actual value over here is 0000000. What is there after at the rate? This is nothing but the timestamp. So if you see up, if I just zoom it up, let me close this, and if I just zoom it up, let us see how does this look. So this timestamp is something like 162003445. Can you guess like what date it is? No. So this is just purely a number. Still we can see it, and like we cannot interpret it as a human readable time. So why do we not interpret it as a human readable time? Because this timestamp is in a particular format. So what is this format? This is Unix time in short, right? So we will discuss about it in some time. Let us see one more thing, like these all values which are there on the right side belongs to which counter? This counter. So if you see that this counter has a name which is CPU usage, then there is a curly braces, and at the end also there is a curly braces, and between it we have few key value pairs. So we have instance. The instance is Ubuntu master. What is instance? Instance is from which machine this CPU utilization is from. So this CPU utilization is of machine Ubuntu master. This CPU utilization is of particular job type, and the job type is CPU usage. This CPU utilization is not of the entire machine, it is of a particular process, and the process name is init, and the PID of this process is 1. Now let us take a closer look on this particular metric. So this thing which is before this curly braces is called as metric name. This is called as metric name. So this entire is the counter. You can call it as a counter. This entire counter has these values with respect to these particular times: one time, second time, third time, fourth, fifth, sixth time. And the things which are present within this curly braces are called as labels. So this particular metric has these labels. One is instance, second is job, third is PID, and fourth is process. So while defining up these counters, I chose the name of the metric to be CPU usage. I chose the label name to be process. I chose what should be there inside it. So we do not have anything like consistent which should be there as per the time series database, that is Prometheus. These all things were decided by me. Although we have few complications with job and instance labels, these are two labels which are discussed like generated automatically, but you can also choose them by yourself. Let us discuss about it in another slide. So if I just say okay, so you can see over here that the PID of the upper one and the below one is different, and the process is different, rest all is the same. So the first is the CPU usage on the same machine, which is Ubuntu master, and the job is also CPU usage, but both of them are fetching the CPU usage of different processes within a machine, right, for different time zones. Now let us go and look something towards timestamp. So now we will see how exactly we read up this timestamp. What is this timestamp? This is a unique timestamp, and like we also called it as epoch time, like POSIX time, or second since the epoch time, and Unix epoch time. What is epoch time? Epoch is nothing but this date. What is this timestamp? This timestamp is the number of seconds which has been passed from this date. And why we prepared it? We prepared it because like timestamp may have slashes, it may have January, February number, but like computer systems, maintaining numbers and like interpreting things using numbers is like faster and easier. Like playing with strings becomes sometimes difficult, and it is also slower than like working with numbers. That's why like this particular format was formed. And in every language, say it be like Python, be it be Java, we have some function which converts the Unix time to human readable time. So obviously you do not have to calculate each second, like saying like from 1st January, then the next day is 2nd January, how many seconds have passed. No, you do not have to do like this. You just need to pass up this particular value as argument to as parameter to the function which is converting the Unix time to human readable time. But I'm just giving you what exactly this means, because people get confused like how should I read this timestamp and what exactly this is. So let us now talk about how does Prometheus store data. So I've already used these words multiple times that Prometheus scraps HTTP endpoints. What exactly this means? First, let us see what is an HTTP endpoint. Endpoint is nothing but a URL which is something like this. So Prometheus always expects that the HTTP URL which is exposing the matrix of the particular monitoring target will be exposed at this path, that is slash matrix. So what we are monitoring a machine whose host name is Ubuntu master, and we are exposing this matrix using HTTP. So there is a server which has been established on that system, and on that server at port 9100 these matrices are always there. So the website is always present. In the similar way, this URL, whenever you hit this URL, you go ahead and hit this URL, this data will be always be there. So if I show you up on my screen, so I have a machine which is this, and this machine is running up this particular matrix exporter. This is nothing but a node exporter. So exporter is something which is exposing up the matrix of a machine. Exporter is like is something like it's a piece of software which runs on the machine which is getting monitored. So how we are running up this exporter, like we will talk about it. But yes, as of now, this has created up a server on that machine, and it is exposing matrix. I can go ahead and click it. So it will show up me this matrix again and again every time I go ahead. So as we always have the website present, in the similar way we have this like page, it will always be there. Next, this is Prometheus. If you see that I have Prometheus installed on my system, it is localhost and it works on port 9090. Always works on port 9090. In a similar way, the node exporter will work on port number 9091. These are the default port of these softwares. So if you see over here that this particular Prometheus server is storing up all the data which is here. How can I like get it? Like how can I know that it is storing everything? So if you see over here that this particular uh, like metric exporter has these values, you can see that it has all of these values. If I go down, it has more values, right? So how can I get them? I can just go ahead and like select any one of this counter. So I will just select any one of this counter and I copy it. I will go to my Prometheus GUI. So as in like if you are using a MySQL, so you have MySQL Workbench. Similarly, if you're using Microsoft SQL, you have SSMS, that is like the Microsoft SQL Management Studio. So when you say that these are few softwares, you just double click on them, you go to an editor and you type in a query, say select star from table name, and all the records of the table come up on your screen. So these are nothing but the client software for your database. In the similar way, like Prometheus provides up this GUI, and this is on web, so it helps you fetch the values like for Prometheus from Prometheus database. So as an example, like this is where like this is the place where you write in the query, and like Prometheus PromQL is really very simple. I will just show you up. So you see that there are so many counters out here. I will select any one of them. I will just copy it and paste it. So whatever counter you need, you just click execute and you see that this counter has a value 0, but this is showing you the latest value of this counter. If you need to see the like all the values which are there from last 5 minutes, I will just add a bracket, say 5m, and I will execute it. So now you see that we have so many values for this counter, and we are just taking in like 5m. This 5m represent all the values from last 5 minutes. So this particular language is very easy. You have to use syntax like this, and like if you want for like some all the values, you just remove this particular curly braces and hit an enter and click select execute, and you see that for all the values you get these like for last 5 minutes, all of the counters, all of the metrics. So this is metric name. So the metric name for different labels, for all different labels will be available for last 5 minutes, right? So this is a very simple language to use, and the best part about Prometheus is like it scraps the HTTP. You just need to tell the Prometheus server like what all URLs it has to scrap. What is the meaning of scrap? Scrapping is just it will just take all the text and like store them in the database. This particular symbol is for comment, so it will not scrap this line. It will start scrapping from here. It will scrap it. So let me see if it has scrapped up this value. So I will just copy it. Let me go ahead and paste it over here, and I will say execute. So this is how like you figure out what all metrics are there. So you can, how can you see that what all metrics are there in a Prometheus server? So you can see it from like what exactly you are scrapping. So there is no way like select star from table name, or you cannot see a list of all the metrics which are already over there. Like the best way I feel is like you can go ahead and like you already know what all metrics are being scrapped. You can keep track of these metrics, and like you can pick any one of them. Just go ahead and like pick it. I want to see this. So just go ahead and hit a execute button, and you will see that the latest value was this, and from last 5 minutes what are the values. I will just execute it, and these all are the values from last 5 minutes. Now let us see what all things are available on this web UI. This is a very small web UI, as it does not have so much complexities as we have in SSMS that requires a different administrator for doing it. But yes, like here is the graph part. In graph part you see up this expression and all. So you can just type CPU usage and everything, and obviously as we have discussed, you can just execute the query. So this comes under the graph tab. Then in status tab, we have a lot of different things. Let's discuss about status in a while. Classic UI is just changing up this graph UI panel, and like this is the older one and this is the new one. Like I do not see much of a difference. Obviously, like I have used up the new one, and which is much more easier, and it has less values, less like even handlers than the classic one. If I click on help, it will just open up the documentation of Prometheus, and then I will just move ahead towards status. So in status, we see like the configuration file. So this is the configuration file which tells what all things are being scrapped by Prometheus. By default, Prometheus works on YML, and like we have to give up all of these configuration settings in a format which is YML, and you can see it out here. This is nothing but YML, and it is saying what all things we are monitoring. We are monitoring 9090. We are monitoring 9182. So we are monitoring this matrix which is on 9182, which is this, right? Here is this which is on 9100. So I can see up I'm monitoring on 9100, which are on these IP addresses. So how I have written up this file, we will talk about it. Just take a look as of now in today's chapter. Then if I go ahead, we have some rules. These are the alerting rules. So this particular rule, I will just give you a short glimpse. This particular rule is fired when the instance is down. It is checking up for all the instance. If any of the instance is 0, which means it is down, it will check for 1 minute. It will consistently check for 1 minute. Oh, it is still down, it is still down, it is still down for 1 minute. And if it is still down after 1 minute, it will just throw an email that has been triggered using Alert Manager. So we'll talk about it again. Then we have the targets. These are the targets which are being monitored. These targets are picked up from the configuration file which we just like looked up. So you saw like we had the targets which were 9100 and 9091 for this particular IP address, and on local host we were monitoring these two things. So what is 9182? 9182 is the matrix which has been exposed by the Windows exporter. So I have like created up this particular environment in a way that the Prometheus server, this is the Prometheus server, this is monitoring this machine using node exporter. Node exporter is for monitoring the Linux machine. So this machine is nothing but a Linux machine. You can see that this machine is nothing but a Linux machine. This is my machine which is running on VirtualBox. And if I just go inside this, so you can see that on the command I have something which is waiting. So at the end there is nothing to type. This has paused, and this is nothing but the node server which is running. In a similar way, I am running the push gateway also on this node machine. So we will discuss what exactly is the push gateway and how do we start all of these things. Next is like I am sending up the custom metrics script which has been prepared custom, like I have prepared up the script myself. I have written it in bash, and after writing it I am running it for after every 1 second, and this is actually what is sending up the CPU usage. In a similar way, like I am sending up the memory usage of all the processes within this node machine by myself using the custom like script. So we will see how we are like writing up these things. So here you can see that we have this particular, at the very bottom you can see that we have this particular like area where we can type up new command, but here we do not have these like this particular line, right, which is Ubuntu master at the Ubuntu master, then colon, and then push gateway, and then a dollar sign. We cannot write up anything. This is which, because this is something like which is running a process, that is this server, and because of this like the matrix is being exposed. So this was like a short description on like what environment I have prepared, and like in this environment I will be adding up the service discovery as well in the later chapters. So as of now you see that these machines are being monitored using the scrap metrics, and these has a like the Prometheus server has a web UI which is over here. Then if I go to like the status tab, we have the service discovery. So these are the static like nodes which we are like monitoring. Service discovery is not static. So this does not make actually any sense, but still they are here. These are the runtime like variables which are being used. You can see that the Prometheus is installed over here. This is where the Prometheus is. So how I have started up this Prometheus server, let us look at it. So I will just go to files, and then I will go to Prometheus and Grafana, and then I will go over here. So this is an exe. Prometheus is an exe, I just need to open a command prompt and go to this location and run it. Run this exe. So you see that after running this exe, this has also been stopped. We do not see any C colon, something like that to write up a command, right? So what I did is, like you can see out here, I went up to this place, which is this place, and I just started a exe file, which is prometheus.exe. And you can also see that this particular folder has one more file, which is prometheus.yml. So whenever you download any exporter, anything from Prometheus, so it will have majorly two things. One will be the exe, which you can run, which like you can in command prompt, you just have to say cd and that location, you will move to that location, and then you can just run this exe. And as you run this exe, the server will create automatically by itself, and it will start like exposing the metrics. And what should the Prometheus server monitor? What all, like the endpoints it should monitor, it is present in this prometheus.yml file. The last part which we can see up in this web UI is TSDB status. If I just click over here, so here we can see that the number of series which are there, and like it has a lot of other values. If I go down, it is showing me the top 10 label names. So we are using PID. So these are just the top 10 as per the count, like how many of them are present as per the like time. Then we have top 10 matrices. So you see that as per the count, we have top 10 matrices. So CPU usage, like it has been entered 817 times, and top 10 like labels with as per the memory usage, and similarly like the top 10 label values pairs. Like the job is equal to Prometheus. So again, like this is a very less used information. The major thing is like you have something called as graph, and you can put up the expression and see what are the results. So the next point which I want to discuss up today is Prometheus architecture. So there was a reason that I did not begin this tutorial or this course with Prometheus architecture. I always believe when you see things by your eyes, then it becomes easier for you to understand. So in a similar manner, I have Prometheus server which is running on my Windows machine. So you already know that this is the running Prometheus server on my Windows machine, and it has a YML file which describes what is to be monitored. So whatever you are monitored like is done via pulling up the metrics from HTTP endpoints, and these metrics are triggered by exporters. So these exporters are also like started via the exe file or maybe some executable file. It can be it is not like necessary it should be a exe file. It should be any kind of executable file. You just need to go to the command prompt and you just need to execute it. It will start the server and it will start exposing the metrics out. So as in our case, we are exposing the node matrix. So our node matrix is over here. I will just show you up. So let this open. So if you see up my home page, you can see that we have push gateway and we have node exporter. Right, you can see over here that we have node exporter. So if I just go ahead and like open this node exporter from our home, let me just open it. I will just double click this node exporter, and you see that there is a like a file that is an executable file. You just need to run this file from command prompt, and this is what I have done over here, that I have just run this file from the command prompt. If I just move up over here, you can see up at the very top, you can see that this is an update statement. Okay, let me move a little down. Okay, here, exactly here. So you can see it over here. So you see that I am into node exporter. This is my home. In Linux, this is my home. After home, I did a cd where I like went into node exporter, and I just said this command dot and slash is the present current directory, and it's saying inside this directory please run this. Just run this. I have not done anything else, and this exporter has been started. So after like this export has been started, it is pulling up the server. Similarly, we have a push gateway. What exactly is a push gateway? Push gateway is not the you can say it is not the time series database. It is a memory, it is a cached memory. So let me show you of this gateway. So this gateway should be there on port number, let me just say Prometheus, and here I will just uh, over here and say push gateway. So here I will just say 192.168.0.106. So you see that this push gateway has, like, this push gateway is also nothing but like a URL which you can open up on browser, and this gives us the CPU usage. This is where from it is picking up the CPU usage from this push gateway. But this does not have data, like it only has the latest data. The previous data for previous timestamp, it does not have the data. It is a cache. It is not storing on any hard disk or something like that. It is just maintaining it inside its memory. When you in your code, when you create a variable, it gets stored in your memory, right? Not on the disk. In the similar way, this push gateway is just storing things on its like memory and only the latest things. So I am exposing up CPU and memory. You can see that this is memory. The first one is CPU and the second is memory usage. So my these two files, these two like custom, like which I am telling you, like I have prepared up two custom scripts. These two scripts are sending the data to this particular push gateway, and the Prometheus, this Prometheus is configured to like pull the values. So it has a pull mechanism from this push gateway. So you need to focus on one point out here, and what is the point? If I've said that Prometheus is a pull mechanism software, and why it is a pull mechanism, it do not want to burden the server. So if you are not capable of reaching the machine, there are instances where you say that you are not capable of reaching up the machine, then in that case what you can do is you can use up this push gateway. You can just have your short lived jobs, because when I am fetching the information about the processes, so this bash script will run and it will get over in a second. How will Prometheus take up this data? Right? It cannot take up this data, because like this will run for a second and it will just go off. It does not reside. The HTTP and URL are always there, right? So what are you doing? You are just like saying that please run this script, and you are posting up the results on this push gateway. So as many results you want, you can post it up over here, and then all of these results will be picked up by your Prometheus server. So this is the push gateway, and this push gateway is for short-lived jobs, as I have told you, because these jobs do not live forever. They just live for a time, and after that time, the script gets over. So where is the data? Either you can store it on your like desktop, but it does not make any sense. How will the Prometheus server reach it? No, right? Then there is something called as service discovery, which I have already told you. I will prepare a separate chapter on this. So this is for like making like targeting the containers, and this is also the amazing part of Prometheus, and this is also why it is being used highly in the industry, because in today's world containers is a very like normal thing, and like most of the organization, I will say 99% of the organization are running on containers. So when they are running on containers, they need a software, a monitoring tool which can like identify the containers by itself, and this is what it is doing. Then we have an alert manager to send up the send the emails. Now what exactly is alert manager? If I go up to my again my Prometheus, and then this has the software alert manager. If I have downloaded it, again if I open it, I see a exe file and a YML file. To start alert manager, I just need to like start up this exe in a command prompt. I need to go to the command prompt, I need to go to this location, and then I can just start it. The major part is how to write it and what is the data flow. What is the data flow between Prometheus and then the alert manager? This is again a big topic, and we will cover it in another chapter. The last part is the visualization. So how can you visualize it? You can visualize it using the Prometheus web UI. What is web UI? This is the web UI of Prometheus. What is Grafana? This is Grafana. So we know Grafana, and similarly, like we have the API clients. So if you are a developer, you should already know what is an API, and like you can use the API clients to bind it with another visualization or UI, whichever you want to use. So this is basically the Prometheus architecture. The last part for today is like to understand something about PromQL. So we have already discussed about like the first two types. Like let me try to make you understand these words, the instant vector and range vector. So these are not the querying types, these are just the data types which are supported. You see that it says that it supports floating values and string as per the documentation. I have picked up this from the official documentation. It is saying that it is currently not used. So string is not supported up by Prometheus, but only float is supported up. And we can like query using two ways. One is instant vector and second is range vector. What is a range? Range is as per the time. So instant vector is, I'm just saying CPU usage and I'm just executing. It will show me the instant results. Range vector is I want the result for last 1 hour, 1h. I will say execute. So it will give me the results of last 1 hour for all of them, right? You can see out here. We have the data for all of them. So it will take some time because we have fetched up so much of data. But yes, if I will fetch up only some of it, like as per the labels, if I fetch it like this, then it should be much quicker. So you see that how much quicker it is. So it is the last 1 hour data. So M is for minute, H is for hour. So this is range vector. It is giving me all the values for the 1 hour range. Instant vector is, it is just giving me one value for that particular instant. Only the latest value, right? And this is what like it these word means out here. And there are two more things you can see. One is the offset modifier and second is the at the rate modifier. What is offset modifier? So let me open up a text pad and say that this Prometheus is storing up the values for the CPU utilization, right? What is offset modifier? Let us talk about it. So this utilization is stored at time A, 1, time 2, time 3, time 4, time 5, time 6, time 7, time 8, time 9. Say that. First second, second, third second. Now I want to see the CPU utilization for last 5 seconds. What I will say, I will just say this 5S, right? I will say CPU utilization for 5S and it will give me 1, 2, 3, 4, 5 values, right? But what if I do not want these 5 values? I want these 5 values. What I will say, I will just say offset and I will say 3 second, right? So it will say offset 3 second. First it will move the starting point 3 seconds left and then it will show me 5 values 1, 2, 3, 4, 5, right? Now what is the difference between like the offset modifier and the at the rate modifier? So the first difference is like this at the rate takes up the Unix time. You can see that it is taking up the Unix time. And the second difference is this at the rate means at this time. So I can say that please give me the HTTP request total at this timestamp. So it is not saying that this is an offset, like saying that please give me the records 5 seconds prior to current time. No, it is saying that give me the total number of HTTP requests at this time, right? Second point I want you to see is like these two things, good and bad. So these at the rate should be used just after this curly braces. Offset or at the rate should be used just after this curly braces. If it is being used not after the curly braces, it is invalid. So this is just calculating the sum. So what how you can like do it, like these are nothing but the counters and these counters give us various values. What if you want to take the sum of all the values? You just need to apply a sum function. Last but not the least, like before closing of this chapter, let us discuss about metric types. So Prometheus follows up 4 metric types: counter, gauge, histogram and summary. So let us discuss about them one by one. What exactly is a counter? As the name suggests, is counts. It count number 1, number 2, number 3, number 4, or else it can be reset, but it cannot be decreased. Say, for example, if you are measuring up the memory of the machine or the memory taken by a process, you can say that the process is taking up 5 GB of memory at this time. After 10 seconds, it started taking 4 GB of RAM. After 10 more seconds, it started taking 6 GB of RAM. So it can either increase or decrease. So this particular kind of monitoring metric cannot be taken as counter. What can be taken as counter? So counter, like you can type in a metric saying that how many people have logged in the application till now. So even if you are like logging in 2 times, same user is logging in 2 times, you will consider it an addition, right? So how you can track it? You can track it using a counter, because the number of people who have already logged in and who are logging in again, right? It will always increase. The number will always increase. The first person logs in, the second person logs in. So it is keeping a track the total number of logs in till date in an application. This kind of metric can be considered as a counter. So for example, like in our case, process CPU seconds total is the counter. Why we have taken this as counter? Because the process, like the total number of time which is being taken by the process might be like huge, and we are just tracking it, saying that how many seconds have been passed up as of now and how many users are there in the system. Anyhow, the point to notice, like the counter is something which can only be increased or reset, right? The second data type is gauge, which can be either increased or decreased. For example, like we just discussed about memory, so it can either increase or decrease with respect to time, right? So anything and everything we will talk about is with respect to time. The third is the histogram, and this is something which is important and you should understand. So what is an histogram? So before understanding this, let me tell you the uh, basics how the Prometheus server interprets a histogram. So at first, for Prometheus, this is the metric name. So it is not the complete till underscore sum. No, this is the base name. We call it as base name, and this is the metric name. Underscore sum is something which should always be there with a metric name. Underscore count should be always be there with a metric name. So with one entry, so in gauge and counter with one entry, only one metric and the labels and the value will be put up. But in histogram with one entry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All the 17, like these entries will be put up in one instant, like for one timestamp, right? Similarly, like you can see over here, like these are the application till over here. This is the basic counter name which we can choose. But underscore bucket, this is a convention. This should always be there. And this label LE is also a convention. This should always be there. What does this represent? This represent the percentile. If you people do not know percentile, let me explain you what exactly is percentile. So we all are aware of percentage. We say that out of 100, our marks was say 80 as an average. So I have an 80 percentage, which is the average of total marks which we got. What is percentile? Percentile is a figure which tells the number of candidates which are less than or greater than that particular percentage. For example, if I say that I have 5 subjects, in first subject I scored 45, in second subject I scored like say 43, in third subject I say that I scored 40 out of 50, and in fourth subject I scored say 30, right? So what percentile what percentile of people are greater than 40? This is my question, and the answer will be 75 percentile. How I am getting it? So the total number of people are 4, and 3 people are like greater than 40 or equal to 40. Let me recorrect this statement, or equal to 40. So 3 people are greater than or equal to 40. So we say that 75 percentage of the people are greater than or equal to 40. So 75 percentile like of the people are like greater than 40. So this is something which is not taking up the average. It is percentile tells the number of people which are below a particular value. When we are saying 90 percentile, we say that 90% of the people are like having value less than this or greater than this. So what is the significance of percentile? So to understand the significance of percentile, let us take a scenario in which we are building up an application of, say, like flight reserving app, right? A website which like helps you reserve your flight. So what all things you can do inside this application? You can book a ticket, you can cancel a ticket, you can view your itinerary, and so on. Let's say example, we have already discussed about instrumentation. Like the Prometheus is a very good tool for instrumentation. It keep tracks of how much time like people take, right? So let us see an example where this application has already put up. You can assume this thing that we have already put up like the instrumenting code for booking a ticket. It means that it is just calculating the time taken by a user while he books the ticket. So let's say that the first person come and he books a ticket, and as he books a ticket, like this code takes up say 20 seconds, right? This code takes up 20 seconds. So what will this histogram do? It will update this 20 second over here. The sum is 20, the count is 1, and this value, this 20 value is less than 20 seconds, right? So I will just say that this is something like which is going into this bucket, which is greater than 10, less than infinite. Le means like this is the label which says that this particular bucket is for all the count which are less than 0.005 seconds. You will understand it in a while. Let's assume that the second person came and he took 2 seconds to book a ticket. Maybe at that time there was a lot of load on the server, and that's why it was working slow. So for like that is not a realistic example, because if there will be a lot of load, there will be a lot of entries at that particular time, but let's ignore it, right? The second person came and the second person took like say 5 seconds to book a ticket. So what will like Prometheus do? It will like add 5 over here, it will be 25, the total sum of duration. The total count is 2. It has measured the booking ticket scenario for 2 people, and this time it was like less than 5. So I will say that it will go into the bucket of 5. The third person comes in, and this time like this person takes up like say 1.2 seconds to book a ticket. So it will find up the right place. So 1.2 seconds means it will be 26.2, and the total number of people is 3, and then you can say that it is 1.2, so it should come under say this bucket, right? It is greater than 1 but less than 2.5, so it should be greater than, it should be 1. So out of 3 people who have booked a ticket, one took 2.5, one took 5, and one took 10. In the similar manner, as the people keeps on coming, it will like increase sum, increase count every time. This will be total count, total sum, and these buckets will contain the number of people, the count of people which are as per the LE, that is the bucket length. So this is the bucket upper limit, which is for 0.0 second. So it will keep track of all of this data. So at the end, let's say like there are like 10 people, 10 people took say 100 seconds, and out of 10 people, 2 are over here, say 4 are, 3 are over here, 5, 6, 7, 8, and then I will say 9, and then I will say 10, right? These are the values. So now let's take up a question where I say that what will be the percentile of people whose response time was less than 0.05 seconds or 0.04 second to be specific. So only one person out of 10 had this. So the answer will be 10 percentile. 10 percentile of the total length is less than 0.04 second, right? And this is the purpose of histogram, and this is how like this particular data type is being stored. Last but not the least, the summary data type. So both of them are very same, but histogram saves us, like saves the raw data. It has the different buckets, and these buckets has the upper limit of the response time or the duration. But if you see summary, it has already calculated the quantiles. So in summary, the quantiles are calculated like at the monitoring target end. So that's why like it has a default time for 10 minutes. It calculate the percentiles for 10 minutes and like publish the result. Then it will again like calculate it for another 10 minutes and it will publish the result. But here it is storing of the raw data, right? This is the major difference between summary and percentile, but sorry, histogram. But like both of them, like the agenda of both of them is to store the same kind of data, like you can see that, right? So this brings this chapter to the close. Hope like you were able to understand everything, and please do not like feel awkward in typing in comments. Please do ask me questions if you have any, and please do subscribe my channel, and please share it with your friends. Thank you guys, have a great day.